Hello everyone, this is Deepa from St. Josephs College of Arts and Science for Women, Ozone, belonging to Department of Mathematics. In this video, we will see limit of a function on a real line. Introduction, definition of absolute value function. That is absolute value function on R. Let f mass from R to R be a function defined by f of x equal to greatest integer function x, that is equal to x if x greater than 0, minus x if x less than 0, 0 if x equal to 0. Properties of absolute value function: greatest integer function of 0 equal to 0, a greater than 0 if a not equal to 0, modulus of a equal to modulus of minus a plus b less than or equal to modulus of a plus modulus of b. Rho of x comma x equal to modulus of x minus x equal to 0, that is the distance from a point to itself is 0. Rho of x comma y greater than 0, x not equal to y, the distance between two distinct points is strictly positive. Rho of x comma y equal to rho of y comma x, the distance from x to y is equal to the distance from y to x. And next one is definition of metric. Let X be a non-empty set. Define D maps from X to X by R. Then D is said to be a metric on X if it satisfies the following condition, that is, it should satisfy non-negativity, definiteness, symmetry, and triangle inequality. First one is non-negativity. D of x comma y greater than or equal to 0 for all x comma y belongs to x. Second one is definiteness. D of x comma y equal to 0 if and only if x equal to y. Symmetry. D of x comma y equal to D of y comma x. And triangle inequality, D of x comma y less than or equal to D of x comma z plus D of z comma y for all x comma y comma z belongs to x. Our next definition is metric space. A non-empty set X along with the metric D on X is called metric space. It is denoted by x comma D or simply X. Example, let X equal to R. Define D equal to R by R by D of x comma y equal to modulus of x minus y for all x comma y belongs to R to check whether D is a metric or not. So first condition is non-negativity, that is D of x comma y equal to modulus of x minus y. We know that modulus value always greater than or equal to 0. So modulus of x minus y greater than or equal to 0. Next, definiteness, D of x comma y equal to 0 if and only if modulus of x minus y equal to 0. That implies x minus y equal to 0, that is equal to x equal to y. And next one is symmetry. D of x comma y equal to modulus of x minus y. So modulus of x minus y can be written as minus y minus x, that is equal to modulus of y minus x. Modulus of y minus x equal to D of y comma x. And next, triangle inequality. Consider D of x comma y equal to modulus of x minus y, and this modulus value add and subtract plus z. So modulus of x minus z plus z minus y. So modulus of x minus z minus y minus z. So that is less than or equal to modulus of x minus z plus modulus of z minus y. So this can be written as D of x comma z plus D of z comma y for all x comma y comma z belongs to R. Next, foundation of metric space searching, that is distance searching problem in metric spaces, metric distance measures, similarity queries, basic partitioning principles, principles of similarity query execution, policies to avoid distance competition, metric space transformation, principles of approximate similarity search, advanced issues. Limit of a function on a real line, let a belongs to R and a be a real valued function whose domain includes all points in some open interval a minus h comma a plus h except possibly the point a itself. We say that f of x approaches L as x approaches a. If given epsilon greater than 0, there exists a greater than 0, such that modulus of f of x minus L less than epsilon. In this case, we write limit x tends to a f of x equal to L. Left and right hand limits. The limit extends to a minus f of x is the expected value of f at the point x equal to a. Given the values of f near x to the left of a, this value is known as the left hand limit of f at a. If limit extends to a plus f of x is the expected value of f at x equal to a, given the values of f near x to the right of a, this value is known as the right hand limit of f of x at a. If the right hand and left hand limits exist, then we can say that the limit is exists. That is, if the right hand and left hand limits coincide, we say that the common value as the limit of f of x at x equal to a and denote it by limit extends to a f of x. The limit of a function is represented as f of x reaches L as x tends to limit a such that limit extends to a f of x equal to L. Properties of limits. The limit of sum of two functions is equal to the sum of their limits, so that limit extends to a f of x plus g of x equal to limit extends to a f of x plus limit extends to a g of x. Next one is the limit of any constant function is a constant term, that is limit extends to a c equal to c. The limit of product of the constant and function is equal to the product of constant and the limit of the function, such that a limit extends to a m f of x can be written as m limit extends to a f of x. Last one is quotient rule. Limit extends to a f of x divided by g of x equal to limit extends to a f of x divided by limit extends to a g of x if limit extends to a g of x not equal to 0. Thank you.